Alright guys, so today we'll learn about some common functional groups, their molecular features and their examples. So we'll start with the hydrocarbons. So the hydrocarbons can either be alkanes, they can be alkynes, they can be aromatic hydrocarbons. So they are the subfamily of only carbon and hydrogen without other elements. So usually the alkanes will have this molecular formula C2CN H2N plus 2. So this signifies that whatever value you have for C, the double of that value plus 2 will be for H. So for instance, if I have just a single C here, my H should be 2 times 1 then plus 2, and that's 4. And if I have 2 C's here, let's say I have 2 C's here, then my H should be 2 times 2, which is 4, plus 2, which is 6. And then I'll have 1, 2, 3, 4, 5, and 6H. Alright, so that is it about the alkanes. And another thing to note about the alkanes is the fact that the alkanes are actually single chained. So this is an example of an alkane where we have an ethane which have just one single bond, and here we have alkenes. Alkenes are still hydrocarbons of double bonds, and then they have the general formula CnH2n. Okay, this is a simple example of an alkene. We have 18. So we also have the alkynes, which are triple bonded, and then they have the general formula CnH2n minus 2. So this is CnH2n. Alright, so having known that about these alkynes, a typical example of an alkyne is an ethane. So we have aromatic hydrocarbons too. The aromatic ones are these ones in ring form. So I have benzene as an aromatic hydrocarbon. So we'll go ahead to the next one, which is the alkyl aldehydes. So we have a typical example of an alkyl aldehyde. An alkyl aldehyde is simply a combination of an alkyl group and an aldehyde group. So the X here is representing the aldehydes, which can be fluorine, chlorine, bromine, or iodine. So a good example of an alkyl aldehyde is the chloroethane, also known as the ethyl chloride. It is also important for us to know that an alkyl is formed by removing a hydrogen from an alkane group. For instance, CH4, which is methane, is an alkane, and when I remove one hydrogen, I'll have CH3, which is an alkyl known as the methyl. So this gives us methyl, whereas this is methane. Alright, so having known this, the next thing we'll consider is the alcohols. So the alcohols are the hydroxyl groups. Okay, so we have an alkyl group here added to a hydroxyl to give an alcohol. So this is how their molecular feature would look like. So if I should have an alcohol, it should look like this: an alkyl group attached to a hydroxyl group. So a typical example of this is the ethanol, which has the ethyl group attached to which is an ethyl attached to a hydroxyl group, so making it an ethanol, which is an alcohol. All right, so let's move down further and see the next here. All right, so I have here, I have ethers here. So an ether will have an oxygen atom attached to two alkyl groups. So here I will have an oxygen atom, perhaps a central oxygen atom, and attached to two alkyl groups. So a good example of this is the diethyl ether, where I have an ethyl here and an ethyl here. So these are two alkyl groups attached to an oxygen atom. All right, so the next one is the thiols. So thiols are actually sulfur containing organic compounds. So I have here an alkyl group now attached to this thiol. All right, so this is how their structure will look like: an alkyl group attached to the thiol. So I'll have a good example of this as methyl thiol. So this is a methyl group. So this is a thiol group. So I have methyl thiol. All right. So we also have the disulfide. Usually the disulfide bonds are just simply sulfur to sulfur. So if I have a bond where I have sulfur bonded to sulfur, it is disulfide. Notice that di is two and then sulfide of relating to sulfur. So I have a disulfide here that I can have a molecule having an alkyl group, and then I have sulfur bonded to sulfur, and then an alkyl group over here. And a typical example of this is the dimethyl sulfide, where I have a methyl here, I have my disulfide bond between, and then I have another methyl group. So I have my dimethyl disulfide. All right, so let's go ahead and look at the next. The next is the aldehydes. So aldehyde are simply organic compounds with the CHO functional groups. So you have aldehyde CHO. So aldehydes are CHO. So these are the aldehyde functional groups. So they can actually be represented by this RC, H, and O, where R here is still the alkyl group. So I have an alkyl here, which is a methyl, and then I have my CHO here, showing that this is an aldehyde. So we have this to be an ethanol. We can name this an ethanol, or simply we can call it an acetaldehyde. All right, so let's move to the next one. So the next one is the ketones. So the ketones are simply organic compounds with the CO functional group. Ketones. You notice that? Ketones. So they have the CO functional group. So over here, this is how the structure will always look like, the formula will always look like. So I have two alkyl groups, and then I have my C, and then I have it bonded to O. So this is a typical example of a ketone where I have this bonded to CO. So I have this to be a propanone. So this is a ketone a proper noun. All right, so over here I can also have a carboxylic acid. So the carboxylic acids are organic compounds with the COOH functional group. So carboxylic acids are COOH. So example of a carboxylic acid is the ethanoic acid, where I have CH3COOH. So this is an ethanoic acid. So we have the esters too. We have the esters. So the esters actually are characterized by RCOOR. So they are organic compounds with RCOOR. So a typical example of an ester is methyl ethanoids. So actually esters are more like derivatives from carboxylic acids. So that's why you notice that the esters are almost having the same structural formula as that of carboxylic acids. So a typical example of an ester is the methyl ethanoids. So this is methyl ethanoids. This is R. This is the ester group. Is the last R. So this RCOOR. All right. So we have the amines too, or the amines. We have the amines. So usually amines are nitrogen containing, so it can be RNH2, it can be R2NH, it can be R3N. So simple examples of the amines, we have CH3NH2, which is the methylamine. We have also the dimethylamine. We also have the trimethylamine. All right, so lastly we have the amides, and amides here are also carboxylic acids derivatives. So, but they are actually formed by replacing the OH here by saturated nitrogen. So instead of having your R, C, O, OH, now the OH here will be replaced by saturated nitrogen. So you have this. All right. So a typical example of an amide is the ethanamide. All right, guys. So this will be the end of the class for today. And in our next class, we'll put you through on how you can actually name compounds more. We've learned how we can identify some simple or common functional groups. So stick to us and make sure you subscribe to our channel if you've not subscribed. Also ensure to like our video and share with your friends. Thank you.